Good morning, student. Today we have discussing node voltage method and mass analysis method. First, we have discussing about a Kirchhoff's law. Kirchhoff's law are basically two types: KVL and KCL. KCL means Kirchhoff's current law. It is state that the algebraic sum of at a node incoming current equal to outgoing current is always zero. As shown in a figure, we have show that the one point current I1, I2, I3 and I4, I5 and I6. According to KCL, the point O is minus I1, I2, I3, I4, I5, I6 equals to 0. Means a summation of I0, summation of I equals to always 0. KVL, it states that the algebraic sum of all voltage of all branches around any closed path is equal to 0. Means we have seen the circuit E1 is apply I current flow in a circuit R1 E2 E2, then apply the KVL IR1 minus I2 E2 minus IR2 plus E3 plus E1 equals to 0. Means the summation of voltage drop equals to 0. Node voltage analysis. Node voltage method is the based on define the voltage of each node as an independent variable. The reference node is selected and all other node voltage as reference to the node. The node voltage method define each branch current in terms of the more node voltage is done by using Ohm's law and KCL. Basically, nodes is the depend on Kirchhoff's current law. Since the branch current are defined in terms of node voltage, the current do not exactly enter into the equation. The procedure for voltage: first we have identify all node, then we select and label the reference node, and all other node are reference to this node. Label all n minus 1 remaining nodes. Apply the KCL to each node. Writing the equation, we have take the voltage across V reference is always 0. Solve n minus 1 equation and calculate the value of voltage, current and I relation. This is the numerical. Determine the current in a 5 ohm resistance by using a node method. In numerical, we have seen only two nodes are present. First, we have identify number of nodes where the node is a V1 and V reference. Then V reference always take a ground node. Then we identify the node at first other voltage is V. Then apply the KCL. Then equation I equals to V minus 0 upon 5 equals to V by 5 equation first, and V equation second across the 3 ohm resistance V minus 10 upon 3 I equation second. Equation 3 across 2 ohm resistance V minus 4 upon 2. From above equation 1 2 and 3 we have find out the value of voltage V equals to 160 upon 31. Then again this numerical we have seen. Again we have identify the current in each branch using node voltage method. First we have identified number of nodes. There are the three number of nodes. One identify reference node, other node voltage identify V1 and V2. Solving the equation for V1 and V2, then we have get the answer. Again, mass analysis. Mass current method is based on writing independent mass current equation with mass current are independent variable. Each mass is identified and the direction of mass current is selected. Example, if clockwise, otherwise anti-clockwise, but same for all mass. Mass current method is a depend on KVL, Kirchhoff's voltage law. Solve the all equation, identify the mass current and find the individual branch in a current. Procedure for mass analysis: identify and label the mass current and each define the mass current continuously. Typically mass current are defined in a clockwise direction. Apply the KVL solve the linear equation and get the mass current. And the example, there is a only two number of mass are available. First A, B, E, F. Second B, C, E, B. Two mass are identified in this numerical. Now apply the KVL equation in mass first, then equation V1 we have taking minus 2 plus then plus sign. V1 minus I1 R1 minus R3 I1 minus I2 equals to 0. This is the equation first. Again we identify equation second I1 equals to this I2 R3. Next numerical, determine the current both by using a mass method. There is also two mass. Identify equation first, equation second, and solve the equation. Identify the all branches in current. Value of I1 equals to 1.3 ampere, I2 is the minus 0.34 ampere. Thank you, student.